and they said they will be cheaper. So it was a cost efficiency and environmentally friendly method. So we gave them a chance to try it, and we installed the system, and it has been running since till now. It is working well. It has proven itself in that the temperatures of the cooling coils shows that there is no scale buildup. So we have a very high heat transfer rate through the cooling coils. There has been no detectable deterioration of the transfer rate due to scale formation in the cooling pipes. And there's all indications that we monitor shows that that it's working, and we're getting very good results from it. Some of the reasons why we can say that is we're using less. In general, we used to use 2 pumps to supply enough water for the whole cooling system. Currently, we're only running 1 pump. So in terms of water transferring rate, we also use less water that we need to transfer through the circuit. So that is one of the indications. The temperatures on the probes that we have installed that monitors it on a daily basis also shows to us that the transfer rates are very efficient. So in general, there's a couple of signs that we've been monitoring, and all of them shows to us that it is working. There was an electromagnet one that we tried. That didn't work. We have replaced both cooling coils during this period due to old age. We had a very low delta T over the cooling coils, about 9 degrees. We're currently running about 24 degrees. What is interesting is when we started installing the coils of the WESU system, these old coils were scaled up, and it was busy removing the old scale. As I said, the efficiency, all the parameters on the temperature coils on the coils are excellent. We have a biox process, patented biox process that we are running here on the gold mine. Our ore is very refractory, so what it means is the gold is not accessible with straight cyanidation, direct cyanidation. So we have an interstage step where we use bacteria to oxidize the crystal matrix where the gold is situated inside. This makes the gold accessible for the cyanide. During the process, the bacteria is an exothermic reaction, so it generates heat. We have to remove about 2 megawatts of heat from the process continuously, and that's why we have cooling coils in the reactors where we remove the heat by means of the cooling water. We then send it to 2 cooling towers where by evaporation we cool the temperature down of the water, and we recirculate it back into the reactors. So it's a closed loop circuit. We used to add chemicals to prevent scaling from occurring. Due to that, you have a buildup of, because of the closed loop circuit, you have buildup of calcium carbonates in the water that builds up. Because of the evaporation of the water, the calcium stays behind, and you start getting scaling in the piping. Previously, we added chemicals, and you had a bleed-off stream that you bleed off once in a while to prevent too high buildup of these chemicals. With the WESU system, we can cycle a longer time, so we use less drinking water. So our water consumption has decreased. And what happens, the WESU system scales the carbonates in their reactor, in their system, and not on the piping of the cooling system. So you force the scaling to occur in a place where you can control it, and not in a place where you don't want it to scale. So we can use it in the process. When it flushes, it just goes into our spillage system, and it returns back as processed water. What's nice about this water also is previously, the bacteria being a live organism, the chemicals that was used in the biocides and the chemicals that was used by the other companies is poisonous to the bacteria. So if there was a pipe burst on the cooling system, especially on the connection pipes, it's rubber perishing after a while in the sun, you would get that you immediately have to fix it. Otherwise, the bacteria will be poisoned and your process deteriorates. What's the benefit that we're getting now is if the pipe bursts, there is no harm done to the bacteria. It's clean water, there's no harmful chemicals in it. So yes, the guys must fix it, but it's not a critical fix. It's a fix that you do it due to the temperature's not going right, but you don't have to be concerned that it will poison the system. So that was additional benefit that we gained that we didn't realize at that stage. What we found is where we used to run 2 pumps, we now can get away with 1 pump. It's about a 44 kilowatt motor's power that we're saving at this stage. The amount of water that you save in water is also requires power to get to the point where you use it. That's also a power saving. It's a fairly simple system to maintain. Once a month the WESU comes down and they clean it out and service and check it. It takes them a few hours. The reason why we've outsourced the maintenance is just that because it's not a mainstream process, you might get it, and also because it's new and it was in a trial period, we found that it might be better if they work with it and they maintain it, so that there can't be any risk that they say that we are not maintaining it properly. And yes, speaking to the serviceman, he was also saying it's fairly easy for him to maintain it. It's only necessary for him to come down once a month. At this stage, we found also what he said to me is and I've also inspected it. In the beginning, we had a lot of scale formation in the reactor pipes. Also, the color was more dark, so there was a lot of impurities. The last 2-3 months, we found that the amount of scaling has reduced dramatically, and the color, this last color that we looked at, the scaling is a more whitish calcium carbonate. So it shows you that it's mostly the calcium carbonate that comes from the fresh water. It is working, and I think it's a very low maintenance. You must make sure that all the parameters that is required to be checked, that it's maintained. It is a fairly simple system. The cooling tower packings that we had to replace, we had a sort of a set pattern that we had to every 2 years replace packings on the on a cooling tower. We found that the cooling tower packing stays cleaner, so that also is saving us money. We had to, unfortunately, when it was running for about, I think, 3 months, 4 months, we had to replace the packings in any case. What happened was the WESU system was starting to remove the scaling, but because it was so badly scaled up in the first instance, the scale that came loose were blocking the bottom packing row. So we had to, in any case, remove replace them all. We will be inspecting it in about a month's time to see if we will have to replace it. We've done it in August last year, so this year, August, we'll just do inspection. So it would have been due in another year's time. But at this stage, it looks as if we'll be able to stretch it for a longer period, if not for indefinite, until the packing fails due to normal wear and tear, but not due to scaling of the packing.